In this video, the mechanism of action of digoxin and acute and chronic digoxin toxicity will be explained to you. As you can see on the screen, a very simplified schematic representation of a cardiac myocyte. Inside the cardiac myocyte, you can see a sarcoplasmic reticulum with the calcium stored inside. On the plasma membrane, you can see a sodium-potassium ATPase pump which maintains low sodium inside the cell by transporting sodium outside against its concentration gradient by utilizing energy stored in ATP, and a sodium-calcium exchanger which removes 3 sodium ions in exchange for 1 calcium ion on the expense of energy stored in the sodium gradient. You can also see L-type voltage-gated calcium channel on the plasma membrane. On the sarcoplasmic reticulum, calcium ATPase which transports calcium into the sarcoplasmic reticulum, and a ryanodine receptor which causes calcium release into the cytoplasm. Now, as the action potential reaches the cardiac myocyte, the L-type calcium channel opens and there is influx of calcium ions into the cell. These calcium ions bind to the ryanodine receptors which trigger the release of calcium stored in the sarcoplasmic reticulum in the cytosol. This is known as calcium-induced calcium release. Now, this calcium in the cytosol binds to the contractile proteins, leading to muscle contraction. After the action potential ends for muscle relaxation, the extra calcium in the cytosol is removed by two means. Some of it is pumped back into the sarcoplasmic reticulum via calcium ATPase, and the rest is pumped out of the cell via sodium-calcium exchanger. Now, what happens in the presence of digoxin? Digoxin, which is a cardiac glycoside, inhibits sodium-potassium ATPase pump, which is responsible for keeping the low sodium inside the cell. Now, this inhibition results in higher intracellular levels of sodium, which reduces the ability of sodium-calcium exchanger to transport calcium out of the cell. Well, actually, it acts in reverse, leading to increased intracellular calcium levels. This increased intracellular calcium is pumped into the sarcoplasmic reticulum via calcium ATPase, resulting in increased calcium stores. Now, in the presence of digoxin, when the action potential travels down the cardiac myocyte, there is calcium influx via the L-type calcium channel, which binds to the ryanodine receptors, leading to calcium-induced calcium release. But this time, due to increased calcium stores, more calcium is released, resulting in greater force of contraction and hence increased cardiac output, a positive inotropic effect.